Hello. Okay, so we're looking at day 6 stuff, and we'll peek into a bit of day 7 stuff as well. We're going to start off just by kind of thinking about if you were to add mass to a bungee cord, what would happen to the length of that bungee? And so, hopefully, after doing some other labs and experiments, you guys would realize that the more weight that you put on it, the more mass you put on it, the more it's going to stretch, or the longer the bungee is going to get. We're going to talk more about that, but that's going to kind of start off the lab that we're going to be working on today. We'll also need to do a little bit of recapping the elastic energy lab, and thinking about our system analysis stuff. All right, so for our elastic energy lab, you should have gotten this quadratic relationship, that energy equals some constant times the distance stretch squared. Um, Again, the relationship that you're hopefully noticing is that as you increase the distance stretched, when that doubles, the energy stored is quadrupled. And this again was the lab where we dropped the mass and it stretches the bungee cord when it gets to the bottom. So hopefully that was the relationship that you guys noticed. Now the actual equation for elastic energy is close, but a little bit different. And it's actually 1/2 k d squared, where k is the constant that represents the stretchiness of the elastic band or the spring. And so it's a little bit different equation, but again, pretty similar. What we're going to be working on today is trying to figure out what that K value is for our bungee, for the bungee that we're going to be using for our drop. But now we can go ahead and stick this into our system analysis. And of course, this is on page 2 from our engineering portfolio. And again, we should have most of this stuff kind of figured out at this point. Mass of the jumper, well, that's something that we're going to measure for each jumper. The starting height, right? There's going to be 2 options that the jumper chooses. And again, they're going to tell us at the beginning which jump height they're going to be jumping from, the high or the low one. Added string, this is our overall output, right? This is the thing that we want to know. How much string do we add to the bungee so that when the jumper jumps, the bungee stretches, the string doesn't, and they get just to the right spot. Length of the unstretched bungee cord. Again, this is something that we'll know ahead of time by measuring our bungee cord, because our bungee will not change from jump to jump to jump. The spring constant, or the stretch of the bungee, that K value, we're going to have to do a mini experiment to figure that out. And that's what we're going to be working on today. The distance the cord stretches. Again, this is going to be dependent on that K value. It's linked to what we had just figured out in the last lab, where 1/2 times the spring constant times that distance stretched squared, that's where that distance stretch comes from, right? So if we know the energy and we know the K value, we can solve for how much the bungee is going to stretch. For the next one, we're looking at our height of the jumper. Again, we want to know how tall our jumper is when our jumper jumps, because we don't want them hitting their head on the ground. So every jumper is going to tell us what their height is. For the last part, the ending height, this is going to be a combination of our no-go zone and our buffer. And again, we've got a big old poster that we're going to go ahead and take a look at to try and get the jumper right in the green spot. It's okay if they get into the yellow spot, but not ideal. And then, of course, the red is no good. hitting the ground, even worse. All right, so let's go ahead and think through our mini lab. Again, we might think to ourselves, well, we already have that K value because we just did the energy lab and we know the equation. And that's true that we do have that value. But the energy lab is a lot more prone to mistakes because when we're dropping things, right, things are moving, especially very end, right? They're moving a lot right at the end. So it's really hard to get really accurate data. And although it's great for using it to figure out the mathematical model, the relationship between the stretch and the energy, again, hopefully you found that that was a quadratic relationship. The spring value, if we're just trying to find the spring value, it's actually easier to find using other methods. And so that's what we're going to look at today, is other methods to just make this a little bit easier so that we get even better data. The lab directions for today's lab, pretty straightforward. Again, this is different than what we did last time. Last time we dropped the mass. This time we're going to gently place it, right, and lower it down until it reaches what we call equilibrium. So we want it to just stay there, right? It's not moving, it's not going up or down, it's just staying there. And when it's just hanging there, the bungee should be stretched. So what we need to know is we need to know what mass we're putting on there. We need to know the unstretched bungee, or the starting height of the bungee, the stretched length of the bungee, or the ending height of the bungee. And we're going to just change the mass and repeat this experiment a few times so that we can fill in the data table. Once we have the data table filled in, we can graph it in Desmos and solve for the spring constant. So this data table looks something like this, right? Again, we have our starting mass. If you have the mass value in grams, like 100 grams, you're just going to want to divide that by 1,000 to get that into kilograms. So 100 grams would be 0.1 kilograms. We also want our starting height and our ending height, or our starting length and our ending length of the bungee. Again, the important part here is that we're going to be using those two to figure out the distance stretched. How much did the bungee change when we added mass to it? We also need to graph the force. And so these two things, we have some equations for. And we can see down here, there are some clues to help us with coding. We know that the distance stretched is going to be the starting minus the ending. So again, if you guys are doing it the other way, where you're looking at the starting length and ending length, your ending length is going to be bigger, so you should flip those around, right? Ending length minus starting length will get you the stretch. For me, I put the meter stick where the 0 is at the ground, because that's where I'm going to treat 0. I'm going to start with the unstretched way up high, and then I'm going to add mass to it and see where the ending height ends up being. So for me, my starting value is going to be bigger, and that's why I'm using starting minus ending. The next one we're going to be looking at is the force. And force is just going to be our mass times gravity. In this case, the mass, we are determining which one we put on the bungee. So we're just going to use that mass in kilograms, don't forget. And we're going to multiply that by 9.8, because 9.8 is the gravity for the Earth. Again, once you guys have these all filled out, you should be able to graph these using Desmos. Whatever you guys get for your C value in Desmos, that is your spring constant. It's a spring constant for your elastic bands. You also need to make sure that you guys are paying attention to what elastic bands you are using, because different bands have different spring constants. And if you use a different band on the day of the jump, all of your data is going to be wrong. So you need to make sure that you're using your same bungee, which is why they all have different paperclip colors, so that you know, if you know the two paperclip colors, you can make sure to get your correct bungee each and every time. If you finish that early, which again you should, it's a pretty quick lab, make sure that you guys are finishing any late or missing work from this unit. Remember that this unit does end when winter break starts. So you need to make sure that you have all of your stuff in by then. The FET lab, the elastic energy lab, maybe you need to finish the conclusion of the elastic energy lab, whatever it may be, make sure that you guys are working productively on those things. And then if you've finished up with everything, right, everything's good to go, then you can start work on coding and designing your app. That's mostly a day 7 thing, but we'll just kind of talk about what's going on there, because again, a lot of you guys are going to be getting to that point. All right, so again, starting our coding app, we'll just kind of skip through that. So first off, we're just going to look at a quick checklist of the things that we're going to need for our app. There's a lot of stuff that we need for this app. Just looking at our system analysis, this is the second page of that engineering portfolio, right? This page here. Again, if you haven't been filling this out, it's going to make this a lot harder. If you have, as you go, again, just quickly like putting things in and typing things out. Are we going to get the mass of the jumper? We're going to measure it. Or we're going to ask the jumper. But we're probably just going to measure it because we don't always trust the jumper. So on and so forth. So from our system analysis, these are all the things that it talks about. It talks about knowing the mass of the jumper. It talks about knowing the starting height, how much added string, unstretched bungee, spring constant, distance the bungee stretches, height of the jumper, buffer, ending height, no-go zone. Right? Those are all the different things that are on our system analysis. Some things that aren't really on our system analysis, I mean, they kind of are, but not really. Starting gravitational energy. Right? That's this stuff over here where we talk about that starting energy. So it's sort of on there. Total energy. Remember that the total energy needs to be constant, which means that once we know how much starting gravitational energy there is, that is the total energy, and that should stay constant the whole jump. Ending gravitational energy, again, on the left side of the system analysis, sort of. And then ending elastic energy. So again, these ones are, again, a little bit harder, but we'll kind of take a look at how to figure those things out. All about conservation of energy, all about those bar charts on the left-hand side that you guys should have filled out. So the next thing we're going to do, again, to try and think about how we're going to put this into our app, is we're going to sort this gigantic list. We're going to think about the things that we're going to need as inputs, and we're going to think about the things that we're going to need to calculate. So again, looking through each of these, we can think about how we're going to get the information. Are we going to get the information by calculating something, or are we going to get the information by measuring or asking about something? So pause here, try to sort through this list as best you can, and then we'll kind of go through this together real quick. All right, So let's go ahead and see. And again, if you guys got some of these things in the wrong categories or whatever, no big deal. The inputs, these are experiments or values that we collect ahead of time. So the mass of the jumper, again, we can measure that as they get to the jump itself, right? Quick little measurement of their mass. The starting height, they're going to tell us, right? Do they want to jump from the highest spot or the next spot? Length of the unstretched bungee. Again, this shouldn't change from jump to jump. So you guys should be able to measure this ahead of time and not worry about it. The spring constant. That's the lab that we did today, or day 6, depending on when you're watching this video. And again, that does not change from jump to jump. Your value might be different than somebody else's value, but your value will not change. The height of the jumper. Again, you'd have some way of measuring the height of these jumpers as they come up. For us, measuring the height of our water bottles is pretty easy. The buffer and no-go zone, these are based on the poster, right? This poster that we're going to be using to try and figure out where we're trying to jump to. So that poster is going to be what we measure to figure out the buffer and no-go zone. And then all the other things are going to be calculations, which is actually good because once we set it up, the computer is going to do all the calculating for us. Calculating starting gravitational, calculating the total energy, calculating the gravitational at the end, calculating the elastic energy at the end, calculating how much string needs to be added, calculating the bungee stretch, and calculating the ending height. All of these things have a formula for them. And so we're going to go ahead and look at those formulas, but they're all based on either the inputs or other calculations. Now, when you guys are designing your app, you're going to be thinking about these inputs, you're going to be thinking about these calculations, and thinking about what makes the most sense for the design layout of your app. So we know all the parts, we know what's an input, we know what's a calculation. Some things to think about are what are the things that the operator, right? The jump operator, you, when you are dropping your water bottle, what are you going to be changing the most, right? Are those easily accessible? Are those easy to find and easy to change? And what is the output? What is the overall output that you're going to want? Make sure those things are super visible, super easy to get to. All the other stuff should be hidden, right? We want to make it as user-friendly as possible. Again, these calculations should come from our system analysis page. We talked about the starting gravitational energy being the mass of the jumper times the starting height times gravity, or 9.8. We talked about the total energy has to equal that starting gravitational, right? Because that's all the energy that you start with. And that energy has to be conserved. That is the total energy. That's the total starting energy. That's the total energy at the end. That never changes. The ending gravitational, mass times ending height times gravity. Again, based on where we want them to end, where we want them to stop. Ending elastic energy, we get by subtracting, right? We know that the total energy at the end is composed of ending gravitational and ending elastic. So if we subtract the ending gravitational from the total, we get the ending elastic energy. We know how much energy is stored in the elastic band. To find the distance that the bungee stretches, right? This is just a rearranging of that equation that we were working on the other day, where we saw that elastic energy equals 1/2 kx squared. This time we want the x by itself. So we rearrange things and we get that the ending elastic energy times 2 divided by the spring constant. And if you raise all of that to the 0.5 power, which is the same thing as taking the square root, you'll get the distance the bungee stretches. Again, you don't need to know how to get there, right? You're just going to need to use that equation. The ending height, again, we're going to measure the no-go zone. We're going to measure the buffer. And when you add those together, you get your ending height, where you want them to end. Added string. This is the final calculation. This is the most important part. This is the part that the operator wants. They want to know, how much string do I add to the bungee so that the person can have a fun bungee jump? We know how much the bungee is going to stretch. We just need to know how much string to get them to just the right location. And the way that we're going to do this, starting height, where we're starting the jump. We're going to subtract off some things. Subtract off the ending height. Subtract off the height of the jumper. Subtract off the length of the unstretched bungee. Subtract off the distance that the bungee stretches. And what's left is how much string we need to add so that they're in just the right location at just the right time. Again, pause the video here so that you guys can do the coding of your app, right? For the spot that says starting gravitational energy in your equation, right? You're going to type in equals. You're going to click on the square that has the mass of the jumper. You're going to hit Shift 8 to get the multiplication asterisk. You're going to click on the starting height. You're going to do Shift 8 again to get another multiplication asterisk. Multiply it by gravity, which is 9.8. The important part about selecting the cells and not just putting a number like 5 for the mass of the jumper is that the next jumper might not have a mass of 5. And you want to make sure that this value changes according to the mass of the jumper and the starting height. So it's important that it is able to change as those variables change. So again, filling out these equations in your app. And your app starts off blank, 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 blank. I don't even have it up right now. Next, we're going to look at some mock data so that you can test to make sure that your app is in fact calculating things correctly. So again, pause here if you need to finish up those formulas. All right, mock data app test number 1. So the only numbers that you should change are going to be these inputs, right? Go ahead and put these inputs in. And when you're putting them in, don't put the letters. Don't put the units, because then your program won't know how to calculate things. Only put the numbers. So put in a mass of 0.4 for the jumper, a starting height of 4.5 meters, length of the unstretched bungee as 0.35, spring constant of 3, jumper height of 0.3, buffer of 0.1, no-go zone of 0.2, and of course gravity of 9.8. Again, that value can be hard-coded in to your app because gravity is not going to change, right? The only way that would change is if we were on another planet or moon or something like that. So that can be hard-coded in. And what you should get for your output is 0.24 meters. So if all of the coding is done correctly, this is the output that you should get. And if it's not the output that you get, we're going to try and troubleshoot that real quick. So with the numbers that we had, right, these are the output calculations that should show up. So if one of these isn't showing up, that tells you where the mistake is, right? If your starting gravitational energy is something other than 17.6, then your app is not multiplying things correctly to give you the correct starting energy. Remember, that was mgh. So what it should be is our mass times g, or 9.8, times our starting height. So if it multiplies those three things together, that's the value that it should get. And if yours is getting something other than that, again, check the formula, check the input, make sure that your values are calculating correctly. But what you should be getting is 17.6 or 17.64, but it should probably round that off for you. Same thing with all the rest of these. Again, if you're getting something other than these values, that's where your mistake is. Go ahead and fix that. And then hopefully your added string output is done correctly. If you think that everything is working, right? If you think that everything is great, again, you should be able to try some more mock data and double check, right? Again, the only thing you should change are the green values. If you have to change things in the red, you're doing it wrong. Those should automatically update and calculate for you. So here's a new massive jumper, new starting height, all of these values. Make sure that you guys are changing all of those inputs. Again, gravity did not change. I think the buffer and the no-go zone didn't change either. But make sure that you're updating all those values and check to see what the added string needs to be. And again, you should get 1.62 for your output. Again, if something is still wrong, right, then you didn't fix it in the last round. And you need to make sure that you guys fix that so that it works no matter which green inputs you give. And you should go back to mock data 1 to make sure to double check. Keep going back and forth between these until you only have to put in green numbers to get the output that you're desiring. Here's to help troubleshoot. Again, double check the calculations. If these are the things are not showing up, then something is going wrong. If you are really struggling with this app stuff, if you need lots of help with it, the next slide will kind of walk you through how to do that. All right, so again, this video is going to walk you through how to do that stuff so that you guys can check and make sure that you are understanding where all these things come from. Again, it's from the system analysis, just like we had talked about, but he'll actually walk through how to put in those codes. Again, this is not the most user-friendly layout. This is not an A assignment, but it'll get you a passing grade, right? And so if this is something that you need, make sure that you are, in fact, using it. And he'll walk you through how to put in the codes for all the different things and some mock data as well. If you still get stuck, again, let me know, check with a friend, but make sure that you guys are getting the help that you need to be successful. All right, best of luck.